So in 4.5, we're looking at exponential growth and decay. So exponential growth, okay, 2, when we're squaring it or we're raising it to exponents, you've got 2 squared is 4. Then all of a sudden it becomes 8, then 16, then 32, then 64, then 128. It is growing exponentially. Okay, so this is just the models of growth and decay here. If it is growing, it is growth. If it is falling, getting smaller, it's decay. In the models, this is what you have here. So A sub 0 means the initial amount. Okay, so it just means the amount at the beginning. E, okay, that's your exponential growth. K is the growth constant or the decay constant. So if it's positive, it's growth. If it's negative, it's decay. T is time. And we're frozen. So give it a second. Okay, so look at this example here. You have in 2000, the population of Africa was 807 million. By 2011, it had grown to 1,052 million. Use the exponential growth model, okay, in which T is the number of years after 2000 to find the growth rate. Okay, we're looking for the rate here. That models the data. So A sub 0 is the initial amount. So the initial amount is this 807 million. Okay, the amount after time, that's your A, is this 1,052 million. Time is how long lapsed from the initial amount, 2000, to the after time amount, 2011. So our time is going to be 11 years because 2000 and 2011, 11 years passed. So we know everything except for the K. All right, if we plug this in, you've got a 1,052 for your A, an A sub 0 of 807, E is E, K is unknown, time is 11. I'm going to put the 11 in front of the K because K11 just looks weird. And then this is very similar to the problem in the last section where we were finding the time that was unknown. Okay, so isolate the E. So divide both sides by 807. So these will cancel. Let's see. 1052 divided by 807. We get 1, and we'll just do, let's do 3 decimal places, 1.304. Equals E to the 11K. Okay, now E is isolated. We need to get this exponent out from being an exponent. So remember, ln and E are inverses of each other. If you have E in a problem, get rid of that, you would do ln on both sides. So take the natural log on both sides. What ends up happening is this ln 1.304 comes down. ln and E cancel out, so this just becomes 11K. Then you divide by 11, and that will give you your K. So we'll do ln, and see, I already have this in my calculator, so I want to be as accurate as possible, so I'm not going to round. I'm just going to go ln second answer to get this full number here, and then divide that by 11. That's going to give me a 0.024 for my K, which means that the population grew at a rate of 2.4%. Okay, and you can go ahead and check that. Do 807 second E to the 11 times this answer here. So second answer, and we get 1,052. So go ahead and try this practice problem real quick, and then we'll go over it. All right, y'all ready? Okay, so we have the exponential model, A equals 341.9 E to the 0.014 T describes the population, A, of a country in millions, T years after 2003, Use the model to determine when the population of the country will be 450 million. So this 450 million, that's your A. Okay, that's the population. So we're going to plug that in, and that's going to give us our time, T. Okay, so we have 450 equals, and then the rest of the equation, 341.9 e to the 0.014 t. So we will divide both sides by 341.9. So that is going to give us 450 divided by 341.9. So 1.316. Okay, these are going to cancel. I'm going to have e to the 0.014 t. E is now isolated, so I will do natural log on both sides. To cancel out the e, bring the exponent down. So that gives me natural log 1.316 equals 0.014 t. So then I will divide by the 0.014 to isolate the t. Okay, and again, I want the actual time for this. So I'll do natural log, pull this answer, 1.316, divided by 0.014. It's going to give me 19.6 for my time. Then I want to answer the question, how many years after 2003? So add 19.6 to 2003, so that should be what, 2022? So yeah, 2022.6. So in the year 2022, the population will reach 450 million. And that's it for 4.5.